So we got this 1 terabyte Western Digital passport in for recovery from another data recovery shop. And today we're gonna try and solve this issue for them. So this is an older unit. It's dating back to 2010. The drive was making beeping noises. If you put your ear to the drive that makes beeping noises, if you don't hear that it's spinning up, chances are something is stuck on the inside. As soon as we undo all these bolts here, your T6 screws, we will see exactly what we have to deal with. The original head assembly had been already taken out, but the platters are still in original shape. We haven't done anything with the platters yet. Usually the head assembly is going to have some sort of a spacer spreading heads apart. The reason why this one does not have it is because pretty much every head slider that was supposed to be on these arms is no longer there. They're all gone. The drive got stuck and left sliders on the surface. We can only see the top one, and it's right there. Got a little bit of contamination. We'll clean that up. But the job is to split the drive apart and have those sliders picked off the surface of the disk. They simply can't be left there, because as soon as the new head assembly is going to go in, it's going to smash into it and things are going to end up in very, very rough state afterwards. The platter extractor is going to help us with lifting the discs out. So this is the top surface, this is the bottom surface. As you can see right there, that is the second slider. There's another one over there by the edge. But this surface doesn't have it. Head 1 is also missing. And head 0 head 0 has two of them stuck, one right there and one right there. Right there, and another one right down there. And there is the very last one. Now we need to get a new head assembly, and we're almost done. That's it. That's all there is. This drive ends with 66177 serial number. The next thing would be to convert the device from USB interface to SATA. And SATA interface conversion will require extracting content from EEPROM and either programming it or physically moving it to the SATA board. We already read this with the terminal. I'm connected to channel number 3. Because the drive is making these buzzing, beeping sounds on startup, it actually adds a bit more problems to this case. There was a couple of small hints that the drive was giving me to indicate that. Let me just power it up real quick. You can see that it's moving. It's free enough to spin on its own, but as soon as the lid is up on there, the drive is making those buzzing noises. So this is actually turning into a complete overhaul project where pretty much everything gets replaced. We're using a different PCB, we're using a different head assembly, we're using different chassis. Everything but the platters and the content of the EEPROM is going to be new. I should have kept that in there for a bit longer. But with the original spindle, I don't think we're going to make this unit run on its own. So I'm going to use a different chassis for it. Alright, that's good. Parking ramp. So now that the drive is spinning up fine, we're going to launch it up in the utility, and hopefully we're going to get some good news by seeing two registry lights come up down here at the bottom, indicating that the drive is ready for work. In this specific case, it's taking longer than it would normally, but that's fine because the drive is not operating with original heads, first of all, and second of all, we don't know what kind of damage it might have sustained from that fall, so it's slowly crawling back to life. Over here we can see that it's been able to load up. Now it's a good time to take a backup of the entire service area before we do any firmware modification on this drive. Firmware modification is done to prevent any possible issues that the drive may develop. Even though this unit most likely died instantly, because the defects were already on the surface and heads are not original, we want to avoid this drive going into what I'd like to call a hard drive coma, so to speak. That's a slow response issue for Western Digital. So we backed up the regions. Now we can start prepping the firmware of this drive to stabilize the imaging process and make it as painless for the drive as possible. Before we proceed with modification of critical modules, let's verify that the drive is capable of writing, because that's going to be very important. And if we do that, that's preferably to be done on modules that are not important. So we're just going to pick something that is not mission critical. I'm going to change some bits around, record them into the drive. Now we're going to reread it. We see that the changes took place. That means the writing ability is there. I'll return it back, and now we can start working with the critical stuff. We're going to start with module number 32. Clean that up. That's good. Then module 34. Clean that up as well. Recalculate the checksum. That's good. And module 02. That's where most of the modifications will take place to prevent overflow of potential candidate defects that the drive may run across due to slower speeds, problematic areas, etc. While we're at it, we're also gonna disable all the smart features from the drive, because at this point they're not necessary. We just want to take the data off of this unit for the one last time, create a full image off of it. Alright, so let's record that back into the drive. And reset the power. All set. Now just gonna save the log and return the second module back to its original shape. And now we got ourselves a fully recognized drive with data access. This is sector 0. As you can see, it doesn't even have encryption in it. We can start imaging. Okay, now that the task is created, first thing first is build a head map that will calculate which sectors belong to which heads. And once that's done, we can take a duplicate of the file structure and go with selective imaging if we need it. The MFT map is captured. Bitmap is captured. So the drive ended up bringing some special challenges to get this case done, but nonetheless it was pretty straightforward work. As long as there is no platter damage, most of the time recovery will be 100% or close to 100%. And this case was a great example of how something what may sound to be very minimal, very small, can turn into a pretty big job overall. When the drive is making those beeping noises, it's getting power to the motor, but the motor is struggling to rotate. In our case, at first, nothing really screamed that a spindle is damaged. Nothing really said that the platter transplant would be required. The spindle itself was free enough to turn with a screwdriver. Usually that doesn't raise any flags. In some cases we get drives, and even in 2.5-inch form, that just are very hard to turn or don't turn at all. But in this case it was very strange, because when I first loaded up the drive with new components and powered it on and I heard those noises, I mean, there isn't really anything interfering in the drive that will kind of force it not to spin. But being able to troubleshoot this and go backwards one step at a time to find out where the actual issue is laying is very important. And that's what will most likely make or break the case. In our situation, it turned out to be great. So if you guys like this video, don't forget to hit like, put your comments below if you have any questions regarding anything in the process. And if you found yourself in an unfortunate situation where the data is no longer accessible on your device, feel free to check out the description box for the link to our website, and we'll take care of it. For those of you who are following this on a regular basis, thanks guys again for your support. And for those who are new, don't forget to subscribe to this channel if you're into data recovery. This channel is all about data recovery, so I'm pretty sure you're going to find a bunch of interesting content on here for you. Thank you very much. I'll see you guys in the next episode.